So yesterday we started talking a little bit about the unit circle, right? So, again, this is called the unit circle simply because it's a circle centered at the origin, right, with a radius of 1. That's all that means, okay? But just like before, this is still my x-axis. This is still my y-axis, right? So what quadrant is this? Okay, everybody good with that? Yeah? All right, and from where we picked up yesterday, how many degrees is right here? And then here? Right here. 30? Okay. Is everybody okay with the first quadrant? So everything's going to be building from here, right? So if it's 30 degrees from 60 to 90, it'll be 30 degrees from 90 to here. So I'm looking at 120. Okay, 15 degrees between 60 and 45 means I'm 15 degrees different here. Whoops. So that'll be 135. 15 degrees again will be 150, and then 180. Everybody okay so far? Yes, no, maybe? All right. So I'm going to keep building this and fill in all the degrees, and make sure that you have that copied down on your sheet. Well, it's 30, 15, 15, 30, 30, 15, 15, 30. Because the distance from 0 to 30, right, is the same as 180 to this line, but it's also the same as 180 to this line. So this will be 270 degrees, 300 degrees, 315, 330, 360. Is everybody okay with the degrees, you think? Yes, no, maybe? All right, so like I was saying the other day, there's 360 degrees in a circle because that's what the Sumerians figured out. All right, so they're a base 60 culture, so everything in our basic trigonometry really has a 60 at its base. Right, 30 is half a 60, 15 degrees is a quarter of a 60. Yep, so it'll be 210, 225, 240, 270, 300, 315, 330, 360. Okay, everybody good with that, yeah? Okay, now, there are two types of angle measures. Okay, we use degrees as kind of our basic, right? As our default, if you will. But there's also a thing called radians. And a radian is a different way of counting around the circle, but it'll get you to the same spot. Blank space without the degree mark, we're going to use for radians. So this is 0, still. But for radians, everything is based off of a pi. So 180 degrees is the same thing as 1 pi. Okay, 1 pi radians. Is everybody all right with that connection? Yes, no? Okay. So how many degrees is halfway here? Right, so if this is 90 to 180, this will be half a pi. So I write it as pi over 2. Okay, everybody all right with that? Yes, no, maybe? Okay, what's the relationship between 45 and 90? 45 is how big compared to 90? Okay, so 45 times 2 is 90, right? So 45 is half as big as 90. So if 90 is pi over 2 in radians, what's half of a pi over 2? Pi over what? 4. Okay? So just like if we go 45 plus 45, we get 90, right? Plus 45 and then plus 45. In that situation, we're counting by 45 degrees at a time, right? For us, this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. What's 4 over 4 reduced to? 1, so we just get 1 pi. Is everybody okay? So all we're doing is we're creating sectors. We're dividing these up into common measurements that we're going to be working on so we can see what's happening within the unit circle with known numbers. So that way when we start giving you unknown numbers, you'll know how it's going to react. Okay? So what's the relationship between 30 and 180? Because basically if this is 0 degrees and this is pi or 180 degrees, I'm cutting this up, right? So 30 degrees is how much of the 180 degrees? So like what's 180 divided by 30? What? Right, 6. So that means that there's 6 30-degree chunks in one pie, or in 180 degrees, right? There's 1 here, 2, 3, 4, 5, 6. Everybody okay with that? So 30 degrees is 1/6 of the first hemisphere. So if 180 degrees is equal to a pi, what's 30 as a radian? Pi over what? So if pi represents the whole, how many pieces are you dividing? 6 pieces, right? So this is a pi over 6. Are there any questions on how I did that? So all we're doing is we're really just playing with fractions. Okay, we've got 1 pi as a whole. We cut it up into 6 equal pieces. So that means that that is equal to a pi over 6. Okay, how many 60 degrees? So what's the connection between 60 and 180? So what's 180 divided by 60? 3, right? So again, if pi is the whole thing, how many blocks of 60 degrees can I form out of half a circle? Yes, 1 pi is equal to 180 degrees. They both represent half a circle. Yeah, there's 6 pi over 6 chunks, right? So, or 30 degrees. Okay? So how many 60-degree chunks or blocks are there in 180 degrees? What did you say? 3. So this is going to be pi over what? There you go. Is my first quadrant done? Yeah, and I told you yesterday, if you know the first quadrant, you should know everything, right? So all we're going to do now is we're just going to count. Okay, so like if I counted by 30 degrees, right, I'd go from 0 to 30, and then what happens when you add another 30? What do you get? And then 120. Everybody okay? So what if I wanted to do the same thing, but instead of counting with 30 degrees, I'm going to count with pi over 6. So I've got 1 pi over 6 here, right? What's a pi over 6 plus a pi over 6? 2 pi over 6, right? And what's 2 over 6 reduced to? 1/3, right? So it's pi over 3. So 30 plus 30 is 60. Pi over 6 plus a pi over 6 is what? Pi over 3. Huh. Okay. So I'm at 2 pi over 6. What if I add another one? I'm at 3 pi over 6, right? What's 3 over 6 reduced to? 1/2. So this is the same thing as pi over 2. Everybody with me with what I'm doing? Okay, so if I keep that going, 1 pi over 6. Kind of, except we're bigger than halfway. So the fractions, the denominators are going to be the same, but the numerators are going to change. So this is 1 pi over 6, 2 pi over 6, 3 pi over 6, and what's this? 4 pi over 6. But what's 4 over 6 reduced to? So this is 2 pi over 3. Everybody all right? Yes, no? 135. Is that going to be like a 30, a 45, or a 60? Which one does it match up with? The 45. So what's 45 is radians? Pi over 4, right? So let's count by pi over 4s. So 1 pi over 4, what's 2 pi over 4 reduced to? 1/2, so I'm up here, right? And then I'm going 1 more pi over 4, so how many is that? 3 pi over 4. Everybody all right? Yes? No? Maybe? All right, so you're okay with these being right across from each other, right? And these and these. Right, so what that means is that they're going to be built off of the same denominator. They're going to be an added section of the same thing, right? So they're like repeated sectors. So if you look up here, right, this is 60 degrees, right? So what's 60 plus another 60? Which is over here, right? And you see how they share each other? Right, they have the same line. So if I had 1 pi over 3 is here, and I wanted to go over here, right? So 60, you said you just added another 60 to get 120, right? So if I had a pi over 3 and added another pi over 3, what would I get? No, because when you add, that's if you're multiplying. When you add fractions, you're going to make sure that the bottoms are the same, but then the bottom stays. So 1 pi plus another pi is my 2 pi. And when you add, the bottom always stays the same. You only change the bottoms on fractions when you multiply or divide. All right, so this is, so 45, right? Let me get rid of these. All right, so we've got 45 degrees here, right? So what's 45 plus 45? 90, right? 45 plus 45 is 90. And then what's 90 plus 45? 135. So how many 45 degree sectors are there to get to 135? There's one here, right? One here, that's 2. And then one here, that's 3. So 45 plus 45 plus 45 gets me to 135. So if I do the same idea, but with the pi over 4s, right? I get pi over 4 here. And what's a pi over 4 plus another pi over 4? Which reduces to 1 pi over 2, right? And then take 2 pi over 4 and add another one. How many is that? So what's 2 pi over 4 plus a pi over 4? Well, do the bottoms match? 2 pi over 4 plus pi over 4. Okay, so you keep the bottom, and then you just add the top. So what's 2 pi's plus 1 pi? So I get 3 pi over 4. So all I'm really trying to do right now is just show you the connection between the degrees and the radians. Okay, so like if 180, we know that 90 is half of 180, right? 180 is from 0 to here, and 90 is half that. Well, if I change the 180 to a pi, right? Here, to get this one, I take 180 divided by 2 and get 90, right? So instead of saying 180 divided by 2, I said pi. I would get just pi over 2. And that can't reduce, so that's my answer. Okay? What 180 divided by what will get me 30? So 180 divided by 6 will get me 30, right? So instead of taking 180 divided by 30, or divided by 6, what if I took pi? Well, that would be pi over 6. Does that make more sense? That's what I'm really doing for the first quadrant. Where it gets weird over here is because I'm counting from the first quadrant over, so the numerators will get bigger, but the denominators stay exactly the same. So like if I have a pi over 3 here, this point connects over to this point, right? So if you notice the bottoms match, right? Same thing from here to here and here to here. The important thing is that you can count it up. So pi over 6 plus a pi over 6 is 2 pi over 6, which becomes pi over 3, right? 2 pi over 6 plus another pi over 6 is 3 pi over 6. And then this becomes 4 pi over 6, and then this becomes 5 pi over 6. Okay? So I know it's a little weird. We're going to have to spend some time getting used to it. But if you have questions, ask, and I'll do what I can. Okay? I hate to say this, but sometimes the explanations will kind of sound like just learn it. And I know that sounds mean. If that's how it comes out, please get my attention and force me to rephrase it. And if I can't, then tell me, hey, you need to know more. And I'll have a better answer for you on the next day. Okay? Everybody all right with the first 2 quadrants? You think yes, no, maybe? Okay. So if we went from 0 to pi in quadrants 1 and 2, how many radians are there between quadrant 2 to quadrant 4? So if there's 1 pi radians between 0 and 180, how many radians are there between 180 and 360? Right, another pi. So how many pi's would that be? 2 pi. Everybody okay with that? Yes? No? Maybe? All right, so we're going to just keep counting here. So does everybody see that if I dropped an altitude from the 150, it would match up to the 210? Right? Everybody see that, right? So what's the denominator on the 150 as far as radians go? It's a 6, right? So what do you think the denominator here is going to be? It's going to be a 6. So if this is 5 pi over 6, right? How many pi over 6s would it take me to get to here? Well, this is 5. So what's this? 6 pi over 6, right? And real quick, what's 6 over 6? So that leaves me with just 1 pi. Everybody okay with what's going on here? Yeah, I'm counting by 30-degree marks, right? So, like, this is 1, 2, 3, 4, 5 30s. So if this is pi over 6, that's 1, 2, 3, 4, 5 pi over 6. Is everybody kind of making the connection between degrees and radians, though? And what I'm going to tell you is if you can't tell from the way I'm trying to describe it, your brain has a lot more experience with degrees than it does with radians. So if you notice, have you guys noticed I'm trying to knock everything back to degrees first and then just convert it into the fraction for radians? Have you guys noticed that? So your brain's going to naturally think degrees first, and then it'll fill in the radians, but you need to know the connection between both. Yeah, the issue is going to be as long as you can count. Like, if you know that pi over 6 is 30, right, and I want you to hit over here, if you can go 1, 2, 3, 4, 5, 6, 7, 8, that's 8 pi over 6, which is 4 pi over 3. That's what I want. Okay? The issue is that this will tell you the bottoms, but it won't tell you the tops. But it will tell you how many degrees makes one sector by that name, so you know what to count by. This is the degree value, this is the radian value, but mathematically they're exactly the same. Okay? It's just that we're going to be using both types of language. So you need to be able to go and do your trig with radians and with degrees. Okay? Everybody all right with that, yeah? All right. So if this is 5 pi over 6, how many pi over 6s to get us here again? 6, right? This was the 30-degree mark. So every 30 degrees is a pi over 6. So how many degrees to go from 180 to 210? 30. So that's another pi over 6, right? So if this is 6, what's this? How many, if this is 6 pi over 6, how many is this? 7 pi over 6. Everybody okay with that? Yeah? Okay, 225, is that going to be like a 30? Yes. Okay, 225, is that going to be like a pi over 6, a pi over 4, or a pi over 3? Is that going to be like 30, 45, or 60? 45. So its denominator is going to be a 4, right? So now I'm just counting by pi over 4s. So that's 1, 2, 3. This is 4, and again, what's 4 pi over 4 reduced to? Just a pi, which is what I want, right? Everybody okay with that? So if this is 4 pi over 4, how many is this? 5 pi over 4. Everybody okay so far, you think, maybe, possibly? Okay, this one, 240, is that going to be like a 30 or 45 or a 60? A 60, so this is 1 pi over 3, 2 pi over 3, 3 pi over 3, so this is 4 pi over 3. Okay? This down here, the 270, is that going to be like a pi over 6, a pi over 4, a pi over 3, or a pi over 2? Pi over 2. So this is 1 pi over 2, 2 pi over 2, so what's this? Is this starting to make some sense on how I'm counting these or no? And if you want to figure out what it's going to match to, you can move up or across, right? Have you guys noticed that, right? If I take this, 7 pi over 6, and I go straight up, and I go back to the first quadrant, what is it matching up with? Pi over 6, right? So that means that it's got to have the same denominator. All right, here, this one, go up, over, it's got to be a pi over 4, because they're referenced to each other, okay? Yes, sir. Yeah, that's 5 pi over 4, and 4 pi over 3, and 3 pi over 2.
5 pi over
4 pi over 3, and 3 pi over 2. Everybody all right? Okay. 300, is that going to match up to a 60, a 45, or a 30? It's going to be a 60, right? So again, 1, 2, 3, 4. So how many is this? 5. So this is 5 pi over 3. Everybody okay? You think maybe possibly? Okay. What's this one going to be? What's it going to look like? Is it going to be, like, what's its bottom going to be? Is it going to be a 2, 3, 4, or 6? 4. Okay, so while we're thinking about it, what about this one? 6. Okay. So if this is 5 pi over 4, right, where's 6 pi over 4 going to put me? All the way across? Well, what's 6 pi over 4 reduced to? That's 3 over 2, right? So it's actually, so 5 is here, 6 is going to put me here, so how many is this? 7. Which, if you notice, what's the numerator here, odd or even? Odd. It's a 1, this one, 3, 5, 7. Everybody okay with that? Yes, no? All right, so what about for pi over 6? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's this? 11 pi over 6. We are going to need to know the common angles, okay, and I wanted to get this out of the way because what I'm going to show you today is how to convert from radians to degrees or degrees to radians using a little formula that's super quick and easy. But we do need to get to the point to where if I'm referencing 30 or 45 or 60, that doesn't throw you off any more than me saying pi over 6, pi over 4, pi over 3. Okay, it's mainly for the language that your brain goes, pi over 6, that's 30 degrees. So they mean the same thing. Is everybody all right with that, yes or no? Okay, so what's 135 plus 45? It's 180, right? So if this is 3 pi over 4 plus another pi over 4, that'll get me here, right? And how do I go from 180 to 225? That's another 45, right? So if this is 4 pi over 4s, how many to get me here? That'll be a 5 pi over 4. Yeah, all right? Maybe? Okay, what I want you to do is I want you to just kind of stew on this. We're going to come back to this, but later on in the chapter, okay? I just wanted to get this out of the way so when I start talking about radians and degrees, you guys are like, oh, okay. All right, everybody all right with that? Yeah? Okay.